The first part of this problem asks us to sketch the vector as it's described in the problem. So the vector is told to us that it has an angle of 23.4 degrees above the negative x-axis. So if we have a y-axis, then we're looking at the negative axis, which we typically draw pointing to the left for x-axes. So the vector v is pointing at some angle above this negative x-axis. So it might look something like this, where this is vector v, and here is the angle, which is given as 23.4 degrees. The next part of the problem is asking us to find the x position, the x component of the vector, so something like this, which we'll call v sub x, and the y component, which is going to look something like this, v sub y. Now remember that in general, when we have a vector with an angle being measured from a horizontal axis, then the x component is equal to the magnitude of the vector multiplied by the cosine of the angle, whereas the y component is equal to the magnitude times the sine of the angle. So to find v sub x, we just need to take the magnitude of the vector, 24.8, and multiply by the cosine of the angle 23.4 degrees. If we put this into a calculator, then we find the x component to have a magnitude of 22.8 units. But notice, this is the part of the problem where it's important that we have a diagram, because if you look at the diagram, notice that the vector is pointing to the left. The x component of this vector is pointing to the left, in the negative direction. So that means that our x component is going to have a negative value. So using the cosine and sine functions is how we can get a magnitude, but we need to actually look at the diagram to determine its sign. So the x component must be negative. Let's apply the same method to the y component. So again, the magnitude, 24.8 units, multiplied by the sine now of the angle, 23.4 degrees. And if we put this into a calculator, we find a component of 9.85 units. And if we look at the diagram, we can see that the y component is pointing upwards in the positive y direction. So it's going to be positive, and we don't need to worry about the sign in this case. But we've now found both the x component and the y component. Finally, the third part of this problem asks us to use the x and y components to find the magnitude and angle of the vector. This might seem a little weird because the magnitude and angle of the vector are both given to us in the problem, but essentially what's happening is that we're being asked to sort of check our work. So we used the information we were given initially to find the components, and now we're kind of being asked to work backwards from our result to find the givens. And the hint of the problem even tells us that this is a good way to check our work, because we already know what the answer to part C should be, we just need to now show that. And so this is fairly simple as long as you understand the formulas for the magnitude and angles of a vector. You can find the magnitude of a vector by taking the square root of the sum of the squares of its components. So that'll be the square root of vx squared plus vy squared. So that is the square root of the square of negative 22.8 units plus the square of 9.85 units. And if we put that into a calculator, then we find a magnitude of 24.8 units, which checks out because that's the magnitude of the vector that was given to us in the problem. So we know we have this part correct. And now for the angle, recall that the angle is equal to the inverse tangent of the y component divided by the x component of the vector. So that's the inverse tangent of 9.85 divided by 22.8. Put this into a calculator, and we get an angle of 23.4 degrees. So that's our angle, and again it checks out because it matches with what's given. So that's 23.4 degrees above the negative x-axis. And so that is the answer to this problem. And that is it for this video. I hope this video helped you out. If it did, please consider subscribing, as that'll help me out in making more videos just like this. If you have a request or a question, leave a comment down below, and I'll do my best to help you out as best as I can. That's all for now, and I hope you have a lovely day. Bye-bye.